So about bias and part 1 of bias which we are doing. So if this is the result that you have a risk ratio of 2 for the association between diabetes and COVID-19 complications, what are the apprehensions or questions which will arise in your minds? That is the question. Anybody can contribute.
Ma'am, you'd be thinking about the socio-demographic factors of the people, maybe age, gender.
Okay. Okay. What else?
There are
Anything
other
else?
comorbidities, no?
Okay.
Their socioeconomic status.
Okay. So other variables, right?
Yes, ma'am. Yes, ma'am.
Yeah. So you will think of other variables. Okay. What else?
The methodology, sampling, which population they have covered.
Okay. So you will like to know more about the method section. Okay. Anything else?
Even in diabetes, there could be a different population, ma'am. The duration of diabetes, the type of diabetes, or how it affects it. So I need to know about those things as well, ma'am.
Okay. The details of the exposure. Okay.
Yes, ma'am.
Anything else? So basically, when you are trying to do these associations, no, one thing you would like to know is not just one value, but the 95% confidence interval, right? You would want to know the p-values also, probably. Right? You agree with me?
Yes, ma'am. Yes, ma'am.
Because this actually tells you about what the role of chance, right? So you want to know not just one value, but the 95% confidence interval p-value, because it tells us about, I don't know why there is an echo. So, oh my God, why is this happening? Joyce? Okay. So this tells us about the random error. Another question which should arise in your mind is, Anjana said she wants to know more about the method section, because that is going to tell you whether there is bias, right? It's going to tell you whether there is any bias in the study. Then, of course, there are two concepts which we have learned already. We would not want to know how confounders were handled in this study, and whether effect modification was checked. That is, whether the effect of diabetes on COVID-19 complications, whether it varies, say, according to age or according to other presence of, somebody said, other comorbidities. So is there the effect of diabetes or the risk of COVID-19 complications because of diabetes varies according to some other factors. So whenever you're looking at any association, these are some questions which should arise in your mind. Whether the authors have reported the 95% confidence interval, how wide or how narrow it is, what is the p-value telling us? In the discussion section, whether at least bias and confounders have been mentioned. That is what you should strive to search when you're reading articles. So this is exactly what we will be doing. So when you are making any kind of measurements, there are these two important errors which are there, right? So you want to get to the true value. So you measure something, but there are, along with the value which you have measured, there are some errors which are there which you should consider. There are two types of errors, the random errors and the systematic errors. And you all know the definition of bias. What is the definition of bias? Bias is a systematic error. And you should always, to understand what bias is, you should always contrast it with what is known as a random error. Because this random error is what usually you use in your, or you report in your statistical analysis. Whenever you report your 95% confidence intervals, p-values, this is what you're talking about, the random errors. So what I'm trying to say is that in any study, whether you are measuring the prevalence, incidence, or the effect estimates in terms of odds ratios, relative risks, or hazard ratios, you get one value, but there are errors along with that particular value. And these errors are either, you have to consider them as random errors, and you have to also then look at what are the biases which can be in the study. Those are known, those are the systematic errors. So if you understand the difference between these two, because why I took this topic is it took me a long time to really understand what actually bias is. And therefore this attempt to make it as easy as possible for you all to understand. So first let us begin with this random error. Right? So the random error, now supposing you take the example of a weighing scale, and you have a weighing scale which I'm going to take some very extreme examples throughout this particular presentation just so that it is easy to understand this concept. So you have a weighing scale which gives errors of up to 1 kg plus or minus 1 kg, and also sometimes it gives you the correct the correct value, and you don't know uh, at what time this particular value is going to come. So you can't predict anything. There is no consistent pattern in the results. You can't predict, and this variability is just chance fluctuation. Now, when you have such a weighing scale, what is going to be the problem is that it is going to reduce what is known as the precision of your study. Now, this precision is also known as repeatability or reliability of the measurement. Means every time you take the measurement, you are going to have the same result. That is not going to happen with this particular weighing scale. So you say that this weighing scale has low precision. But what happens when you take many numbers for many people and you want to find out the mean value of the particular reading, or you have the same person and you are taking many weights for that person, to get to the correct or the true value, you have to take the average, and the average will be very close to the true value. That is what this random error is. So the error which is occurring in either direction of the true value, it is occurring by chance, it is not predictable. It is going to affect repeatability or precision. But if you take many values and you take an average, so you have plus, minus, and the correct value, lo and behold, you are going to get a value very close to the true value. That is the random error. That is what your 95% confidence interval will tell you. It is going to consider the random error and give you the interval within which the true value is going to lie. Are you with me here?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yeah, thank you. So the next question is, what is the systematic error? So the systematic error is the bias as per the definition. Now, supposing you consider a weighing scale which always shows a weight which is more than plus 1 kg. So it is not going in either direction, it's just in one particular direction, right? And this error is consistent, it is in one direction, it is directional. So what such a kind of a weighing scale is going to do is, it is going to reduce the accuracy, or what is known as the validity of your result. It is not going to take you near the true value, right? It is going to take you away from the true value. Now, this bias is not going to affect the precision, that is a reliability of the study. It is going to affect the validity or accuracy. It is going to decide how close you are going to go to the true value. So, hence it is known as a systematic error. So this error is in a particular direction. Many a times you can't measure this. You don't know in which direction and how much the error is happening in the bias. But this is going to take you away from the truth. Are you getting the difference between random error and systematic error?
Yes, ma'am.
Okay. I really just searching. Yeah. So the next thing which I'm going to talk about is just trying to understand graphically or with the help of figure these concepts. So can you tell me what is just look at the graph. The y-axis is the measurement number, and the y-axis, the x-axis is the measurement number, the y-axis is the measured weight, right? Now, supposing you have every time the measurement is taken, you have the weighing scale. Now, you can see that the true value is 70. And every time the weight is taken, what does the red line tell us? The red cross? That,
Systematic error.
yes,
Systematic
there is a
error.
systematic
Systematic error.
plus kg on the positive side. And what is the blue cross telling us? That the every
Random
time
error.
the weight is taken, the measurement number, every time the measurement is taken, this value can go up and down. But on an average, if you take the average, it will be very close to this value of 70. The same thing is shown on the right side. So you see that all these red crosses, they are together, but they are far away from the truth. This is the truth in the center. So this is systematic error. And all these blue crosses, they are the random error. They are going in either direction. And this, many times you must have seen a figure where this type of a figure is used to explain reliability and validity of a study. So these are very close concepts, closely related to random error and systematic error. So the red one is the systematic error or the bias. A systematic means there is magnitude and there is directionality to this error. Now, you also must remember that there will be weighing scales which will give you absolutely correct values, right? So they will give you values which are correct. There will be no random error or there will be no systematic error. Now you have, again, there would be weighing scales which will have both kinds of error. You should remember that this is the scenario which you usually see in your studies. So there will be studies in which you will have both the random errors as well as the systematic errors, and the random errors you will have to report in your analysis, in your results section, and the systematic errors you will have to consider in your methodology and then mention it as a limitation in your discussion section. So I will just go a little bit deeper into this understanding of the random error and the systematic error. So what are random errors? They are variations which occur by chance. They are inherent in all research. So this random error, because you never study the whole population, you study samples. Whenever you study a sample, the random error is going to be there. It cannot be eliminated, right? So it can be estimated, however, in your statistical inferences by considering, as I told you, the p-values and the confidence intervals. This also I have told you that it affects the precision. Now these are the synonyms which you all know for precision, and this random error depends upon the degree of individual or inter-individual variability. More is the individual or inter-individual variability, more will be the random error. The magnitude of the differences which you are looking at, if the differences per se between individuals are more or groups are more, the random error is going to be more. And interestingly, it also depends upon the sample size. This is inversely related to the sample size. So what happens? Random errors are not predictable, right? But you can reduce them. And how can you reduce the random errors? By increasing your sample size. So this is a very important thing. So when you increase the sample size, you all know that the confidence interval becomes narrow. So it means you are improving on your precision or your reliability by increasing your sample size. So the concept of random error is very different from your concept of bias. So bias is a systematic error. Now this is how to remember this. Always think of what a random error is, and then this concept of bias will be more clear. And this occurs because you have something in your method section, in your design and conduct of the study, because of which you are taken away from the truth. So you are not getting the correct estimate of the association between the exposure and the outcome or any other estimate, because there is a mistake and error in your design. And the result is that when I say you go away from the truth, means there is a true measure of association. You are either underestimating or overestimating that measure. That is what happens because of bias. So it is a systematic error which has magnitude and direction, and it results in inaccuracy, it affects your validity, and it does not affect your 95% confidence interval, but it gives you a wrong estimate. And then all the efforts you have put in are futile. This is something you should remember. Bias has nothing to do with sample size. You cannot say I will increase my sample size and I will reduce bias. That is not possible. This is a very important difference from random error. And like your confounding or your effect estimate, you cannot really do great adjustment in the analysis. But there are some things in the analysis which you can do, which I will discuss later on. But you cannot really adjust for or do anything to handle bias in your analysis satisfactorily. So we have to realize that you cannot correct bias. It's going to ruin your study. So the best thing is prevention. Prevention by having a robust methods section. So what do you need to do is identify, when you write your methods section, you should ask yourself certain set of questions and try and identify whether there will be biases and try and prevent them in your design phase itself, in your planning and in your design phase itself. Now, when you are doing your study, you are selecting a sample, you get a sample statistic. Actually, what happens, because you are never going to be satisfied with your sample statistic. You always want to move from the sample statistic to a population parameter, right? So you have a true causal association in your population. Your study gives you some result based on the data you have collected. But as I told you, there are these questions which you need to ask. So you are studying a particular effect of the exposure on the outcome. You should ask, okay, am I interested in any variable which is an effect modifier? What I'm going to do with my confounders? But this is of interest for us today. I have told you what random error is. And you have to ask yourself whether you have calculated sufficient sample size for your study and you have enrolled sufficient people in your study. And from the bias perspective, you have to ask yourself two questions about selection bias and information bias. So when you want to infer your population parameter from your sample statistic, these are the different things which come into picture, which you should consider in your methods section. So I have told you all that there are many things. Interestingly, we have covered your effect modification. We have also covered confounding. I have told you a little bit about random error. Random sampling error is basically a concept in statistics. And what we are going to really do is today look at what biases are and focus on selection bias, which is a type of bias. So if you are asked a question on bias, at least two types of bias you should remember. These are selection bias and information bias. Now, what is this selection bias? Now, you know that you have a target population. From the target population, you have your source population. And you from the source population, you have your study population. And this study population is your sample. And it has to be of sufficient size to reduce your random error, but it should also be representative of the source population. Now, if your observed sample, right, is not reflective of your source population, that is known as selection bias. Now, sometimes you are very good at your sampling and you get a very good representative sample, but the data, there is an issue with the data collection, which leads to what is known as an information bias. Now, these two are different types of biases. So the selection bias, why can a selection bias occur? The selection bias can occur because of your sampling method. It can occur because you have not taken correct inclusion exclusion criteria or because of attrition. Now, this is another concept which I'm introducing, where I'm saying that if there is loss to follow up, that leads to selection bias. So we'll see about it in the upcoming slides. And when does information bias occurs? Because you have a problem in data collection, you do not have a robust tool, you do not have good questions or methods to collect the actual data, or even your personnel who are collecting data not well trained and are committing errors. So these are the two different types of biases, and we are going to focus on the first part, which is the selection bias. So can anyone tell me now what is selection bias? Bias, remember, is a systematic error. Now this we all know by heart, it's systematic error. But what does this mean, systematic error? That it is not random. It is occurring in a particular direction and consistently with some magnitude in a particular direction, because of which it is taking us away from the